Hi, everyone. My name is Maximilian. Welcome to today's episode of the TelcoBridges Podcast. I'm joined once again by Luc Morissette, our VP of Client Technical Services here at TelcoBridges. Today's episode is going to be pretty exciting. In terms of the agenda, we're going to cover some history on the industry, kind of from closed end-to-end systems to open internet-based systems. We're going to talk about the importance of training and education in today's work environment. And finally, what happened to FreeSBC and what is ProSBC Lab? So Luc, thanks for joining me again. I'd like to kick off today's episode and hand the mic over to you quite literally. Would love to hear a little bit more about what the industry was like when you first joined. What was it like to get onboarded and to learn how everything worked? And maybe we can then talk about some of the key changes from then to now and then what training and onboarding looks like today.
Sure, absolutely. So when I started, it was Nortel, Alcatel, Siemens, Ericsson. They were dominating the voice market, right? Here we're talking more about the voice market. They had these systems installed everywhere around the world, right? So these are worldwide system deployments. I get asked this question a lot. Also, is that it's the same protocols that are being used everywhere with minor differences, but it's all the same protocols all over the world. They had implementation from these not service providers, but manufacturers. The way they did those equipment, it was a multi-year project. They had design specifications. They had discussions on how they could do the signaling and the voice transport. Then they started constructing these devices multi-year to they do this. It was super documented, super tested, right? And then when it got installed in the field, it was very reliable and doing all the functions that was needed. Okay, to learn these equipments, to learn how to use the equipment was very difficult, right? So there was rudimentary interfaces. Computers started not so long ago, right? So then these Telecom were built on those interfaces, so pretty rudimentary. So it took a lot of training to do learn how to use these equipments. So you had to go maybe, 6 months to train on this type of equipment, right? And then you would become the expert of this equipment. One manufacturer would usually provide most of the solution for a customer, with add-ons maybe of different things. Like, for example, I sort of remember that the voicemail system was almost uniquely one company providing the voicemail system for all these manufacturers. And but the rest was that these companies were doing this. They're all a little bit different, but in the end, it provides the same services, a bit different, very complete, very reliable.
But one of the key things is, did you have to use the equipment yourself? Like, did you get to use it as part of training and as part of learning about it? Like, or is it the kind of thing you can study without actually using the devices or the equipment?
No. The reason is that these documentation are not publicly available. Only if you buy the equipment can you have this documentation. If you just read the documentation, it's going to take you forever to try to understand these products. So no, you had to go with that company, get the training from them, and you would have to be dedicated to these equipments. And then you have multiple equipments, so one or a group of person for one equipment, another.
Got it. That's helpful. And then since then, there have been a number of key industry changes, right? So we're talking about mobile, we're talking about VoIP, and maybe we can talk a little bit more about what those things are. But what's different for you in terms of how people now learn about the space or become familiar with the tooling in the industry?
Yeah. Okay. So to just come back on what you mentioned, the core network was built over time, right? And this was a very reliable core network. So what happened is that any new technology would have to link into this core network. So initially it was just analog lines going to customers. They still exist today, these analog lines. Some of them have been removed, but they're still there. But then over time, we wanted to have the mobile services available. So then what they did is they developed, of course, the mobile device. They developed a mobile switching center and base station so they could gather the voice traffic from the phones. The first phones were voice only, right? And then go in the core network. So we just patched in the regular core network so you could interact with anybody on analog lines or any other services. Then they added data on the mobile phones, right? So now data were going on the voice channels of the mobile phones, right? So data was really not so important at the time. Today is really different. It's completely the opposite, right? It's data, this data stream is there, and then you have the voice, which is just some packets out of those data stream. And then I forgot what you asked me initially. Can you go back to what you
I was referring to? I was asking about like the onboarding tools and training. Are things different today with how people learn about the space and what they need to learn?
Okay, so I went a bit off track on that. I still want to talk about that. So the mobile switching centers, the base station, also very, very difficult to learn, very specific. So the documentation is only to that. So when you wanted to get trained, you had no choice. You had to get trained with those companies. If we talk about today, it's changed a lot, right? So the learning curve is much less than it used to be because it's built on previous things that existed. So if you know some of these things, the new things also become more easy to learn. However, it's not just one provider of all these equipment. You have one provider for this equipment, one provider for this equipment, because it has some specific functions and advantages. And so you will choose all of them, but then they all have different documentation, different ways of using it. And you need to get trained on all of these equipments separately.
Right. That makes sense. But this also is related to the inherent design of closed peer-to-peer, end-to-end, wireline systems versus IP packets take the least congested route as fast as possible and get split up and re-put together at the end. And effectively, that key change is what led to some of what you're talking about, right? Like it basically opened it up and it went from a world of a handful of large vendors to, much more competitive, much more open, and onboarding becomes easier.
Yes, and it was those large service providers. Now I'm talking about the service providers using those equipments. So they had to add lines, physical lines, to reach all those subscribers all around the world. But then today, today, 30 years back, this IP network was starting. Right. And then the IP network at the time, I remember, was not reliable, was not necessarily super redundant. It was failing. It was slow. So at the time, the voice traffic on the IP network was like, we think it's going to work, but it was not there yet. But over time, it got better and better. And today is really good, actually. So you can carry your voice traffic over this IP network, which is very redundant. And then they put like huge pipes between cities to pass like tremendous amount of data. So even if your voice traffic is in there, it just passes seamlessly with low delay. Also through all the paths in the world. And now your calls can go all around the world easily, right?
Yeah, that's interesting. And we were just talking about offline that the ratio of data to voice packets is so extreme that in most cases, it's not even worth trying to isolate capacity for voice packets because there's just kind of like so little of it relative to data, which is just
absolutely
so big and ever increasing.
And when I mentioned that the IP network was not so reliable, that's what we had to do, right? We had to put quality of service. The voice traffic was going on the same link, but had priority over everything else so that we didn't lose our voice traffic, because it needs to be real time. You need to have your packets coming in very frequently and precisely, try not to lose any packets in between. So
I think this is one of the elements that I find really interesting about telecom when we talk about technology and telecom versus technology and like traditional kind of SaaS widget software delivery. It's this like robustness that is imposed by the latency requirements, the fact that packets have to be processed in real time, and regulatory things like 911. Like those things taken together means there's like a different burden on the technology working than just whether my website loads quite as fast as it could, or whether something buffers quite as fast as it could, or whatever, hosted in AWS somewhere. And so there's an interesting there's a different feel when people talk about technology, and there's a different like series of steps to validate and to make sure and to roll out and to et cetera, because of that, what's imposed by those expectations. I think that's really interesting.
Yeah, absolutely. You're right. Like websites, what happens is that they launch multiple websites, and then if one fails or is unavailable, just go to the other website. Took half a second more. Okay, fine. You don't notice the difference. For 911, it's like, no, you need to have all the information right now going, and don't cut this call until it's resolved and everything. So yeah, there's constraints that you don't have in other networks.
Can we go back to mobile for a second, actually? Because I'd love for you to explain to me the difference. Obviously the increasing. Am I correct in understanding that the mobile just refers to the last mile?
Yes.
Got it.
That's right. So I explained that briefly before. It's you have your mobile phone. It reaches a base station, goes to the mobile switching center. Once you've reached that, then it's the core network. You just pipe it into the core network. Core network interfaces with anything else out there. Of course, there's some junction points between service providers where you have high traffic between video service providers, and all the rest is managed by that service provider. But it's the rest is core network.
Right, because if there's fiber from the tower to the base station, then that fiber looks a lot like fiber in other nodes. It's really just the key difference, what makes it special and really feel special from a user perspective, right? It feels pretty special to have these things like in your pocket all the time, and it feels like it's wherever you go. The innovation is just between the tower and the phone, and then your phone kind of hops from tower to tower, and then it creates this special experience for the user.
And today you see you don't lose much of your call, even if you're driving on the highway. I remember at the time it was a disaster, right? Because you would lose your call as you were driving. But today it's not. That's the base station. A lot of work has been put in that part, and the phones also keeping the battery. One of the things we discussed this week was that the voice encoding in phones is using AMR. Right, and the core voice network on voice over IP is usually G711. So sometimes you need to convert between those two transcoding.
So Luc, what is different than today for engineers coming into the voice space? What should they be focused on? How does someone get ramped up, and how does someone learn as much as they can?
A lot of questions. So the way it used to work before is that you get training on equipment, very formal, could take weeks or months to train on some products. Today you have multiple products that are being used, multiple solutions. Some of them open source, some of them closed, some of them completely supported. And it's probably a mix of that in a network today. You have engineers that are trained for networks, core network, how to make that make sure the delay is good, they don't lose any packets, you have redundancy. You have others that are trained more in voice type traffic, which is different. It's mostly subscribers, what the services are provided to the subscribers, making sure they don't lose the calls that they are currently doing, have details on all the calls that were generated to be able to bill customers correctly on all of these. So you need to have training on all of these different equipments, right? Most of the engineers today don't have just one task. They do multitask, right? So they need to manage this system and that system and this system, and training on all of this is needed. But then again, you don't have enough time necessarily to get trained. So you need to usually read documentation, try the system, and then get trained, and then do it again maybe 2-3 times so that you get familiar with the equipments that you are using.
That makes sense. And what about the role of open source in all of this? Because we're in a space where there's, pretty robust open source solutions out there that are pretty easy for people to get their hands on. So does that play a factor in people's learning and ramp up?
Yes and no, meaning that we are using open source tools today. One of the most known is Wireshark. Right, so you can learn by yourself Wireshark, or you can get training on Wireshark and learn how to use this tool to really understand what's going on in your network. But usually when you have open source, you need to do just a bit more work, more research, more testing. So it's a little bit different. Closed products are usually better documented, more specific use cases that you can just follow and do that. And both are valid. Right. So if the open source does what you need, it's great. And if you need someone to integrate that, and sometimes it's problematic if you lose your personnel, right? If they leave, then you need to transfer that to the next person. It doesn't have necessarily all the documentation available, or not all the knowledge. So maybe the ramp up is a bit more difficult. The rest, for example, you could buy a training from someone to get your training up, or your skills up to level, right?
Right. There's also security comes to mind too for training, right? Like there's fraud, there's understanding how firewalls have to work and how that interacts with the packets and the voice packets, and then the registration of the users and endpoints and all that stuff. Like that must be a pretty tricky thing to get caught up on.
I think today in all the trainings, you at least have one session on security. I was mentioning to a customer yesterday, if you put a line on the network, right, on the wide area network without any protection, 5 minutes you get hacked. 5 minutes, right? So you absolutely need day one, the first time you put it on the system, on the network, that it's secure. Depending on the type of equipment, different types of security. For us, these are voice services. So of course, you don't want to have illegal calls coming into your system. You can also check if there's fraudulence coming from fraudulent sources. So there's all kinds of things there, in addition to the basic IP firewall type protection. Right.
Okay, thanks, Dick. That's helpful. And what about for ProSBC? What kind of resources do we make available for folks looking to get caught up on how it works?
So first, we have our documentation site, which is open to anybody who wants to get the information there. There's some use cases, there's some configuration guides to use the system. There is then the forums, which you can go there, ask questions. You will get answers quickly on topics that you have towards the free ProSBC. And then we have trainings, open trainings on YouTube. You can just go on our TelcoBridges YouTube channel, and then you have access to those videos. And then we do also sometimes live trainings. And we can have also personalized trainings if it's needed, online or on site even. All right, my turn now to ask a question. When we launched this SBC, we went with a FreeSBC product. Okay, it is not open source. It is our software base, but it was free. Okay, then we came up with ProSBC, but then recently something happened. Do you want to talk about that?
Yeah, sure. Happy to explain a little bit more about it. When FreeSBC was originally launched, it was launched with this idea of training, which we've talked about all episode. We wanted to make it easier for folks to install it in their lab or install it at home, learn how it works, similar to the way they would access an open source solution and learn how that works and walk themselves through it. And so we knew that with the combination of a free product and good documentation and good resources, people would be able to learn quickly and figure out how the system worked. Over time, it proved to be a successful initiative, but we were finding more and more that FreeSBC was used in a production environment and was basically being used in a way that it wasn't designed to be used for. And that led us to kind of just re-examine what resources we were making available to people, because this concept of training and this concept of people wanting to learn how ProSBC works, that remains really important to us. And so what we've done is we've introduced ProSBC Lab, which is specifically designed as a training product. And we hope that it's going to be as popular and as successful as FreeSBC was. And so what we want people to continue to experiment with and learn how to use ProSBC with ProSBC Lab moving forward.
Right. So I know ProSBC Lab has all the features of ProSBC, running even the same versions as ProSBC, but it's limited to like 3 sessions, right, per system.
Yeah, that's right. So the session limitation is a little bit different. Hopefully still enough to experience and experiment with the system. But it's improved, that's right, in that it's now running and will always run the most up-to-date software version that we have, whereas FreeSBC was running an outdated version of the software, which we felt no longer even really represented where the product was at. And so, we're hoping that people still feel they have the resources they need.
Right, correct. Because the product is evolving a lot still today with new features coming out. So I think it's a good idea, the ProSBC Lab.
That's right. Having the most up-to-date version, I think, is really important. And we continue to invest in our R&D team, and we continue to invest in making our product as good as it can be. And we want to make sure that people experimenting with ProSBC Lab have all of the bells and whistles, so that it's a better representation of what it can do.
And how can you get the ProSBC Lab?
Yeah, so for people interested in ProSBC Lab, there's a few things I would say. So first of all, the ProSBC Lab is available from our customer dashboard on our website, just like any of our ProSBC licensed products. It's also not restricted in terms of the number of users for the license. So many different people can operate the same lab license. And so it's encouraged to kind of share. The other thing I would say is we now offer a free trial for our full license. So another avenue for learning how things work is getting the full, higher capacity license on a free trial basis. So you can really put call traffic through or simulate call traffic through it and experiment with more capacity before ultimately making a purchase decision.
Correct. This is the regular ProSBC edition.
That's right. So in addition, ProSBC Lab is one thing. And then also we offer a free trial for new dashboard registrants making their first ProSBC purchase. Well, Luc, thanks again for joining me on today's episode. For anybody interested in learning more, please feel free to visit the links in the show notes. And do not hesitate to head to our website to download ProSBC Lab and start using ProSBC today.